Hello, this is Jorge Moctezuma and I'm writing the part 3. I'm taking the video from Word because I found out that having the video in my phone just to pass it to my computer will be a lot more process, so I realized I'm gonna do it this way. So yeah, um, I'm really bad at physics, but I really tried this one, so I hope it's okay. I hope I did it right because I can't understand what I did. So yeah. So first step, it's take the time a water faucet takes to fill a one little container. So is this one, it takes seconds. I don't know what do I put centimeters in here. I guess 2 a.m. it's not a good hour to make this word. So it takes 5.47 and it was at 33 centimeters of height. Then we have point two, measure the, well, let's ignore this one for now. Point two, measure the diameter of the faucet and calculate its area. So we have it here, 2.5 diameter, that is equal to 1.25 radius, that is equal, when you make the process of P, it's, no, area, it's equal P multiplied by radio at the square. I think that's how you say it. But here you have it. It's 4.9087. That's the area. We're good at this point. So then convert 1 liter to meters square cubic meters and calculate the expensive and speed at which the water leaves the faucet. So here is the convert part. So it 1 liter it's equal to 0.001 meters at the cubic. I'm so sorry. I'm so bad at this. And well, this is the part I must freak out because I really didn't understand what was happening. I take a lot of time to this, so I hope it's right, and I hope I didn't mess up because this is the second time I do the experiment because I realized that the first time I messed up and try and end up doing something that was really different. So I hope this one is right because today is the last day. Okay. Oh, I hope you found that funny. I hope you thought that was funny. So we have this one because we have that Q is equal to volume over time. So volume is this one and time is time it takes to fulfill. So we get the results of the speed. Wait, no, no, the expense. Something. Yeah, the expand that we get from here, pow, 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 and then I realized I didn't know how to take velocity, but I realized that we can change this one to this one, just substituting to get this. So yeah, we have it in, and that's how we get our velocity. And then we have repeat the experiment on a higher faucet and compare the speeds. So then we have all the point two, like this is the second try. It was 24.92 seconds to fill the bottle, and it was at a height of 42 centimeters of the ground. Then we have the diameter of that exit of water. It was 1.17 diameter, that is equal to 0.85 radius, which using the same formula that the last than this part, the first part, we can get 2.2698 area. Okay, and then we repeat the part of this formula here to get this one, and with that we can make a substitution and change the velocity out and put the q in, and then we get our second velocity. So 5 part with I write like 4 because I just did this one straight out. So point 4, that is 5. Calculate the pressure difference of two faucets using Bernoulli's principle. And This was horrible. I didn't have the idea of how to do this, so I hope I did it right. So first we need to have row. I think we say row in English too. And I think that one is pressure. Yeah, pressure, gravity, height, one plus the half of p, velocity one at the cube, and that's the same for the second one. So first we need those values. We have gravity that it's gonna be always 9.81, and the height, and we have it for measure how we got our first part. So we do a multiplication with that, and we can get our p. Then to get rho, we need to do the multiplication of these three parts that I only write the results because I thought it was really large and I was getting out of space already. And after that, we just substitute values and we have that this really long number that I'm afraid to read because I don't know how to read numbers is the result. I actually don't know how to explain the result using the Bernoulli's principle formula. I think that this will be enough that I show you how I did it and that told you that I really tried. So this may be wrong, this may don't be wrong, but I tried, and that's the important part. But so we have that. It's just really long, so I put it, the second part down here and the first one up here. So this is the first part, and this is the second one. Really long. I kind of understand what I did, so I hope it's useful. And this explication of what I did, I hope it was enough to you understand what I did too. So thank you. This was my 7 minute long explanation of what I did. Thank you. And forgive my soul for for being bad at physics. I'm trying. I know I say it a lot of times, but I really try to make this well. I ask people to explain me, and I didn't understand that. So I think at the end I got a good result, and I think I made it the right way. So I'm sorry.